Terrestrial planets, also known as rocky planets, are planets that are primarily composed of silicate rocks or metals and have solid surfaces. They are distinct from gas giants, which are composed mostly of hydrogen and helium. The terrestrial planets in our solar system are Mercury, Venus, Earth, and Mars. These planets are located in the inner part of the solar system, closer to the Sun. Terrestrial planets share several key characteristics. These planets have a solid crust made of rocks and metals, unlike gas giants, which do not have a clearly defined surface. Compared to gas giants, terrestrial planets are much smaller in size and mass. For example, Earth's radius is about 6,371 kilometers, while Jupiter's is 69,911 kilometers. Terrestrial planets have either no moons or only a few. For instance, Earth has one moon. Mars has two small moons, Phobos and Deimos, while Mercury and Venus have none. Unlike gas giants, terrestrial planets do not have ring systems. Proximity to the Sun. These planets are located closer to the Sun, inside the frost line, where temperatures are too high for volatile substances like water, methane, and ammonia to condense into ice. Terrestrial planets typically have a layered structure consisting of three main parts. The core is made primarily of metal, typically iron and nickel. The size and composition of the core can vary. For instance, Earth's core is partly liquid, the outer core, and partly solid, the inner core, while Mars has a smaller, mostly solid core. Surrounding the core is the mantle, composed of silicate rocks that are semi-solid and can slowly flow. The mantle is responsible for tectonic activity, if present. The outermost layer is the crust, a solid shell of rock that forms the surface of the planet. The crust varies in thickness from planet to planet and is where most geological activity occurs, such as volcanic eruptions, mountain formation, and earthquakes. Mercury is the smallest terrestrial planet with a radius of about 2,440 kilometers, making it slightly larger than Earth's moon. Mercury has a very thin atmosphere, composed mainly of oxygen, sodium, hydrogen, and helium. Its atmosphere is so thin that it is considered an exosphere rather than a true atmosphere. Mercury's surface is heavily cratered, similar to the Moon, indicating it has been geologically inactive for billions of years. There are large plains and scarps, steep cliffs, that indicate past tectonic activity. Due to its proximity to the Sun, temperatures on Mercury's surface can reach up to 430 degrees Celsius (800 degrees Fahrenheit) during the day, but drop to minus 180 degrees Celsius (minus 290 degrees Fahrenheit) at night due to the lack of a thick atmosphere to retain heat. Mercury has a weak magnetic field, about 1% as strong as Earth's. Venus is often called Earth's sister planet due to its similar size and mass. It has a radius of about 6,051 kilometers, only slightly smaller than Earth. Venus has a thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid. This atmosphere creates an extreme greenhouse effect, trapping heat and making Venus the hottest planet in the solar system, with surface temperatures around 465 degrees Celsius (870 degrees Fahrenheit). The surface of Venus is obscured by thick clouds but has been mapped using radar. It has volcanic plains, large highland regions, and evidence of volcanic activity. The planet has no plate tectonics, but the surface shows signs of periodic resurfacing, possibly due to volcanic activity. Venus has a very slow and retrograde rotation, meaning it rotates in the opposite direction to most planets. A day on Venus, one full rotation, is longer than its year, its orbit around the Sun. Earth is the largest terrestrial planet with a radius of about 6,371 kilometers. Earth's atmosphere is composed primarily of nitrogen, 78%, and oxygen, 21%, with traces of argon, carbon dioxide, and water vapor. It supports life and regulates the planet's climate through the greenhouse effect. Earth has a dynamic surface, with tectonic plates that move and shift, causing earthquakes, volcanic activity, and the creation of mountains. It has large bodies of liquid water, which cover about 70% of the surface. Earth has a strong magnetic field generated by its liquid outer core. This magnetic field protects the planet from harmful solar radiation. Earth is the only known planet to support life, thanks to its moderate temperatures, liquid water, and atmosphere. Mars, the red planet, has a radius of about 3,390 kilometers, about half the size of Earth. Mars has a thin atmosphere composed mainly of carbon dioxide, with traces of nitrogen and argon. This thin atmosphere provides little protection from solar radiation and cannot support liquid water on the surface for extended periods. Mars has some of the tallest volcanoes and the largest canyon in the solar system. Olympus Mons is the tallest volcano, and Valles Marineris is a massive canyon system. There is evidence that liquid water once flowed on Mars, and ice is present at its poles and beneath the surface. Mars is much colder than Earth, with average surface temperatures around -60 degrees Celsius, -80 degrees Fahrenheit, but temperatures can vary significantly depending on the location and time of day. Mars lacks a global magnetic field, though some regions of the crust are magnetized, indicating that it may have had a magnetic field in the past. Beyond our solar system, astronomers have discovered many exoplanets, planets orbiting other stars that may be terrestrial in nature. Some notable types include super-Earths. These are planets that have a mass larger than Earth's but smaller than Uranus or Neptune. Super-Earths may be rocky and are considered prime candidates for habitability. Potentially habitable exoplanets. Several terrestrial exoplanets have been discovered in the habitable zone of their parent stars, where conditions might be right for liquid water to exist. Planets like Proxima Centauri b and TRAPPIST-1e are examples. Terrestrial planets may exhibit various degrees of geological activity. Tectonic activity. Earth is the only known planet with active plate tectonics. Tectonic activity results in earthquakes, volcanic eruptions, and the creation of mountain ranges. Venus and Mars show evidence of volcanic activity, though the activity on Mars appears to be ancient, while Venus might still experience volcanic eruptions. Mercury, being geologically inactive, is heavily cratered, while Earth's surface has been reshaped by erosion and tectonic activity, erasing many craters. Mercury has almost no atmosphere, leading to extreme temperature fluctuations. Venus' dense atmosphere creates an intense greenhouse effect, leading to extremely high surface temperatures. Earth. The moderate greenhouse effect regulates temperatures, allowing liquid water and a stable climate. Mars. Thin atmosphere leads to cold temperatures, and the lack of protection from solar radiation means surface conditions are harsh. Of the terrestrial planets, Earth is the only one known to support life. Mars is considered a prime candidate for future exploration due to the potential for past liquid water and the possibility of subsurface life. Venus is currently too hostile to support life as we know it, though some scientists speculate that microbial life could exist in the planet's upper atmosphere. Terrestrial planets form through a process called accretion in the protoplanetary disk around the Sun. Planetesimals collided and merged, forming larger bodies known as protoplanets. Over millions of years, these protoplanets cleared their orbits of smaller debris and became fully formed terrestrial planets. This process likely occurred in a similar way in other star systems. leading to the formation of terrestrial exoplanets. Terrestrial planets, particularly Earth, play a crucial role in shaping the solar system. Their smaller size and composition make them distinct from the outer gas giants, and their proximity to the sun affects their temperatures and atmospheric conditions. Earth's unique conditions have allowed life to flourish, making it a special case among terrestrial planets. Terrestrial planets are fascinating objects, with unique geological and atmospheric conditions that set them apart from other types of planets. While Earth is the only planet known to support life, studying the other terrestrial planets, like Mars and Venus, helps us understand planetary evolution, potential habitability, and the processes that shape planets across the universe. With ongoing exploration and discovery, our understanding of terrestrial planets will continue to grow.